Dangers of radioactivity. This is the last lesson in the topic about radiation. Okay, this lesson we have three objectives. What are the dangers of ionizing radiation? Secondly, what precautions should be taken to protect people? And thirdly, what is the difference between contamination and irradiation? First objective, what are the dangers of ionizing radiation? In the picture on the left, you can see a man who has radiation burns. He was an emergency worker who was one of the first into the Chernobyl nuclear plant, which you can see on the right, after the reactor exploded in 1986. He didn't have any protective clothing and was exposed to large amounts of radiation, and you can see the red burns on his skin. There are three levels of radiation exposure. If you get very small doses of radiation, then generally there's very little damage is caused, and the damage that does occur can be repaired by the body. Higher doses of ionizing radiation actually damage the DNA molecules, they ionize them, and that can cause cancer over a longer period of time. If you're exposed to very high doses of ionizing radiation, that can actually kill the cells outright, and that's what radiation burns are. The cells are actually being destroyed. There are other damage to other parts of the body. So the eyes can suffer from cataracts, which is when the lenses go cloudy. The thyroid can be damaged and you can get cancer of the thyroid. The lungs can be damaged if something is inhaled. The stomach can be damaged if radioactive material is swallowed. Radiation can also cause sterility, so the testes and the ovaries stop producing sperm and eggs. And we've looked at skin burns already. And finally, the bone marrow, which is constantly producing red and white blood cells, can be affected, and you can get leukemia, which is cancer of the blood cells.
Hello, I'm Dr. Ziad Kazi, a medical toxicologist working with the Centers for Disease Control and Prevention. Scientists have been studying the effects of radiation on the body for over 100 years, so we know quite a bit about how radiation interacts with living tissue. Let's take a closer look at how the amount of radiation our bodies receive, otherwise known as the dose, can affect the cells in our bodies.
Once a cell is damaged by ionizing radiation, three things can happen. One possibility is that the cell can repair itself. The cell would then go back to normal. Another possibility is that the damage is not repaired or is misrepaired, so the cell is altered. This alteration may eventually lead to cancer. The third possibility is that there is too much damage to the cell and the cell dies. Cell death is not always a bad option. In addition to dose, the health effects of radiation also depend on the dose rate, or how fast the dose is received. If a person receives a dose over an extended period of time, the health impact won't be as severe as if the dose were received all at once. If the dose is delivered to a portion of the body, the health impact won't be as severe as if the dose were delivered to the whole body. Individual sensitivity to radiation is also a factor. Children and young adults are more likely to develop the late effects of radiation. Young age increases risk for two reasons. Younger people have more cells that are dividing rapidly and tissues that are growing. And they have a longer lifespan ahead of them, giving cancers time to develop.
Remember, radiation can affect the body in a number of ways, and the effects of exposure may not be known for many years. For low doses of radiation, there may be no health effects at all. If the dose of radiation is high, medical professionals may perform tests or conduct regular screening to detect and treat health effects. For more information on how radiation interacts with the body, please visit our website.
This picture shows quite a lot of information about the effects of exposure to radiation, and it was produced after the Fukushima disaster in Japan, when the nuclear power plant was damaged by a tsunami. So on the right, it shows you the level of exposure in units called sieverts, and you can see that the normal exposure that we get over the course of a year is about this 1.002 sieverts. An X-ray is much less than that. So going and having X-ray is actually much less than we're normally exposed to. Getting up into the orange areas, these are when it can start to cause damage, and the red areas are where it can be fatal. Here, I'll leave this up and you can have a look yourself. Again, it just shows the sort of effects on the body, and these are the chances of dying from different doses, whether you have medical help or not. So you can see if you're getting above 8, then pretty much you're going to have not much chance of surviving. Objective 2, what precautions can we take to protect people who have to use radiation? The intensity of the radiation decreases the further away you are from it. So people who have to handle radioactive sources will always use tongs or tweezers to do so. Radiation is stored in boxes that are lined with lead, because lead is a very dense metal and it will absorb all of the alpha, beta or gamma radiation. There's a larger box and you can see the lead blocks attached to it. And these are the sort of sources we use at school. And these are the lead boxes, and there's a little well inside. There's the lid, which is lead, and this is the actual radioactive source. If you look at it, it's open at this end, and this is where the radiation will come out. So it's important that should never be pointed at anybody. Ionizing radiation can cause damage, such as burns to tissues. It can also cause mutations in the DNA in cells. This damage can lead to cancer or other health problems. The damage caused by radiation can build up over time, so it's important that anyone working with radiation takes precautions to keep their exposure as low as possible. Scientists working in laboratories usually wear gloves and lab coats to stop any radioactive material getting onto their skin or clothing. Someone who gets radioactive material on their skin or inside them has been contaminated. Just being near a radioactive source can lead to irradiation. Radioactive sources are therefore handled using tweezers or tongs to keep them as far away from the body as possible. The scientist is also wearing a badge that monitors the amount of radiation she is exposed to. Sources should never be pointed at anyone and should always be stored in a lead-lined box and locked away safely when they're not being used. Ionizing radiation is used in hospitals for diagnosing and treating patients. The amount of radiation that the patient receives is kept as low as possible. Medical staff keep their exposure to irradiation low by staying as far away from the source of the radiation as they can. This radiographer is protecting herself from irradiation by controlling the machine from a different room. Some patients need to be injected with radioactive sources. The medical staff wear gloves and protective clothing to stop themselves being contaminated. The nuclear power station at Fukushima in Japan suffered a nuclear accident in 2011 after a tsunami damaged part of it. These workers are repairing the damage. Their overalls help to protect them against irradiation and stop them becoming contaminated by radioactive material. Contamination by radioactive material can lead to more exposure than irradiation, as the exposure continues for as long as the radioactive material is on or in the body. When the workers come off duty, they shower in their protective clothing to wash off any radioactive material. This stops their clothing becoming contaminated when they take their overalls off. They are also carefully checked to make sure no radioactive material has got inside their protective clothing. Third objective, what is the difference between contamination and radiation? Someone is irradiated if they are exposed to alpha, beta or gamma radiation. So in this picture, this is the radioactive source and this person is exposed to radiation. If that person moves away, then the radiation stops. Someone is contaminated if they get particles of radioactive material onto their skin or inside their body. They will be exposed to radiation from this material, and this will continue until it has all decayed or until the contamination is removed. Contamination can get inside the body if it is breathed in or swallowed. Here, the radiographer waits behind a protective screen to protect against irradiation. You can see the patient is having a scan. The radiographer is behind a protective screen. In this picture, the workers are cleaning up after an accident at a nuclear reactor. So they're wearing gloves, goggles to protect their clothing from being contaminated, and they're wearing masks so that they don't inhale anything and become contaminated internally. Okay, so that's all for now. As usual, I'd like you to complete the recap quiz and have a go at least one worksheet. If you try the worksheet number 3, that's the one that summarises what we've done in this lesson. Also, there is a series about the Chernobyl nuclear disaster which you might like to watch. I think it's on Netflix, so if you've got access to Netflix, why not have a look at that?